Hi students, myself SS Jagirdar, inviting you for online classes in engineering mathematics. Dear students, as you know, already 3 lectures we have completed, lecture 1, lecture 2, lecture 3, in which continuously we are discussing about the joint probability. So, in 3 lectures, we have completed the whole concept of the joint probability and related all the terms and quantities which we have to calculate, all we have discussed in details. Now is the time to deal with the examples. So here I am, this session or this lecture is dedicated to the examples. So let us begin with the examples. So there are 4 types of examples I am discussing here: type 1, type 2, type 3, type 4. I have divided so that it could be convenient for you that for which kind of example, what strategy or what steps you have to follow. So dear students, now type 1 first we will discuss, and in type 1 you will find that the joint probability table will be given as a data in the example. So taking that all the entries and all the data, some of the quantities you are asked to calculate or estimate. So that is your job. So let us begin. So now first I will just give you a brief detail of the theoretical detail of the first type of examples. So let us begin. A joint probability distribution. Now in this, examples based on the joint probability table that we are taking, and this is the table that you are aware. In the theory we have discussed about this table. There are so many boxes you can see. The topmost row is that of y, random variable y values are there, and in the extreme left column you can find the random variable x, whose values are given x1, x2, x3 like that, and in between all the boxes filled up with the notation j11, j12, jij and jmn like that. So all those values are the values of the probability of the pair of the values of random variable x and random variable y. So this table is very important, and this will be given in the example. So taking this table, you have to proceed to find out what quantities. Let us see. So now you have to first prepare the marginal distribution of random variable x and y. So marginal distribution table we have discussed how to prepare the table. So that is our first thing. For example, here you know that to prepare the marginal distributions of x, you have to sum the entries or add the entries along the row against the x, and to get the random the marginal distributions of the random variable y, you have to add you have to take the sum of the entries along the column against y. So this is the procedure that you know. So let us see how it is. Once you obtain, you will get it. But first I will go back and I will once again just show you that how you are going to take up the sum. So let us go back, and this is your table. In this table, suppose you want to find out the marginal distribution of x1. Let's begin with the x1. So when you want x1, you have to add j11, j12, j1j, j1n. All these values along the row against x1 will give you fx1, which is the marginal distribution of x1. The similar way you can go to the next x2. When you take x2, you have to add j21, j22, j2i, j2j and j2n. This way you can get the fx2. So this way till the end, the last value of the random variable x is xm. When you come to the xm, all the j values you have to add: j m1, j m2, j mj, j mn. when you add all them or you take sum of all these entries, you will get fxm, that is the marginal distribution of xm. So this way you will get all the entries. Now next, when you take up these entries, now you can put up, see here, how will you put up x1, xi and fxi, this chart you can prepare, which is called as the marginal distribution of random variable x. In this, x1, fx1, x2, fx2, xi, fxi, xm, fxm. This is very important, and this will be the question in the exam about the problem, that you have to find out the marginal distribution of x. In a similar manner, you can go out and find out the marginal distribution of y. So for y, what you have to do? Let us go back. When you go back, you can see in the table that now you have to go along the column. You have to go along the column. For example, if you want the marginal distribution of y1, then add all j values. But which j values? Along the column against y1. Along the column, that is y1, j11, j21, j2i, 2j and j2m. So these all values when you add, you will get gy1. This is gy1 is the symbol for the marginal distribution of the, or it is the marginal distribution function of the y1. So similarly, y2, next column you have to add up j12, j22, ji2 and jm2. This way all values you will add against y2 column values, then you will get this. So similarly, the last one, that is yn. So j1n, j2n, jin and jmn. So this way when you get, then you can prepare the table just we have seen here. This is the marginal distribution of random variable y. This is how you get the values here. So this way random variable of x, that is marginal distribution of random variable x, random distribution of marginal distribution of random variable y. This is our first requirement. Okay. After getting this, what is your next job? So next you will go for yes, this are the random variables when you are taken. Next, what will be asked? Next you will be asked this, you see, expectations. Next you have to calculate, after preparing the marginal distribution tables, you have to calculate the expectations. So three kinds of expectations are here required. What? Expectation of x, expectation of y, expectation of x and y. So now what are the formulas for expectation of x? This all in detail we have discussed in the theory class, but here I am taking simply the formulas and the quantities. The first quantity, expectation of x, whose symbol is ex, and what is the, and another symbol is mu x, and what is the formula? Sigma xi fxi, sigma xi fxi. This you have to calculate. Similar manner, expectation of y is E of y, mu y, sigma yj gyj, sigma yj gyj. And when you come to the third one, that is expectation of xy, xy you see, I am just giving you caution that when you write exy, no comma is put between x and y. You can observe in the picture. In the slide you can see. So then its formula is like this: sigma xi, sigma yj and sigma xi, yj and jij. So this way you can calculate this. So this calculation is next. So this calculation will be inquired, and after getting these three values, expectation of x, expectation of y, expectation of xy, and for, please remember, for expectation of x you require the marginal distribution chart of random variable x. For expectation of y you require the random variable chart of the random variable y, and for expectation of x and y you require the JP table, that is joint probability table you require, because Jij values are required. So these three tables will help you in calculation. So in example we will see how we can do. When you get expectation of x, when you get expectation of y, when you get expectation of xy, next is covariance of x and y. Covariance of x and y. Covariance of x and y, as we have discussed the symbol, it is the double sigma. It is the double sigma, sigma sigma xi yj jij, xy yj jij minus mu x, that is expectation of x, mu y, that is expectation of y. But simply you can see that it is nothing but expectation of xy minus mu x mu y, means upper three quantities that we have calculated, mu x, mu y and expectation of xy, these three will be taken. That means these three will be taken and they will be used to calculate the covariance of xy. Expectation of xy minus expectation of x minus into expectation of y. So this way covariance is obtained by calculating these three expectation and putting in the formula. So this way, this is our problem. So in most of the problems only this much is asked, and when you complete, the problem is also complete. But in some of the problems, one more quantity is asked to estimate. What is that quantity? That is nothing but correlation. That is nothing but correlation of x and y. If you are asked to find out the correlation of x and y, then its symbol is rho x comma y, covariance of xy divided by rho sigma x sigma y. So you can see that here sigma x and sigma y are nothing but standard deviation. They are the standard deviation of x and standard deviation of the y. SD of x, SD of y. SD of x is sigma x, SD of y is sigma y. And how to calculate sigma x and sigma y for the purpose to calculate the correlation of x and y, you can see very easily in the slide that the standard deviation of x is equal to sigma x is equal to root of Vx, and Vx is variance. It is called as the variance, and Vx, and what is the formula of Vx? Vx is equal to sigma x square is equal to sigma of xi square into fxi. That means sigma of product of these two you have to take up. Then in this product you have to subtract the square of the expectation of x. Similarly, to obtain the standard deviation of the y, you have to take up the quantity what? Sigma y. Sigma y is equal to root of Vy. Vy is what? Vy is nothing but it is variance of y, and then you want the Vy. How we have to calculate the Vy? To calculate the Vy, which is variance of y, is equal to sigma yj square into gyj minus mu y square. What does it mean? It means that sigma of product of two quantities, that is yi square and gyj, first you have to take up the sigma of this, and in that you have to subtract the expectation square of the expectation of the y. And when you get sigma x, sigma y, already you have calculated covariance of x and y, then you have to go for calculating the correlation of xy. Correlation of xy formula is what? In numerator, covariance of x and y divided by sigma x sigma y. So this way you can calculate these quantities. So this is exactly the first type of problem requires these all details. Now dear students, I want to tell that in exam 80% of the problems are of this kind, in which either you are asked to calculate the covariance, in which you have to calculate expectation of x, expectation of y, expectation of x, y. Next, in some problems correlation also is inquired. When you have got correlation, when you are, for that purpose you have to go for SD, that is standard deviation. And how to calculate standard deviation? Just you can see on the slide, standard deviation sigma x is equal to root of Vx, and Vx is equal to sigma of xi square into fxi, and this sigma, in this sigma you have to subtract mu x, this is expectation of x. In the similar manner you can calculate the sigma y is equal to root of Vy, And how Vy is calculated? Which is variance of the y. Vy is equal to sigma yj square into gyj, and this sigma, in this sigma value you have to subtract the value of the y, expectation of y. So in this way these two are the quantities which will appear in the denominator of the formula of correlation. Correlation of xy is equal to covariance of x comma y divided by sigma x sigma y. So this way you can see that this is the full stuff of the question that could be asked, and as I have told, this is very important example, because most of the examples, 80% of the examples in previous exams we have found of this kind. So this is exactly the total theoretical part. Let us begin with an example. So let us begin one example that we are taking. So here just I will take up a chart, JP chart, and I will show you that how will you calculate expectation of x and expectation of y and expectation of this. So now you see that in this table, if you want first marginal, so okay, this itself is the first example, so I will go to the example directly. Just I will go to the example. This all you can calculate on the basis of this. Now you see this is the example type 1 JP table based. It is based on the JP table, that is joint probability table. Now you can see the example is like this. This table is given and you are asked to determine what? Marginal distributions, and you are asked to determine the covariance. Here covariance is asked, covariance between the discrete random variable x and y, x and y of the joint probability distribution. So this is, and this is the question which has been there in the model question paper number 1. Therefore I am taking that example for your benefit, that you will be benefited, because this is a most probable example which could be asked in the exam. So therefore we will take up this example as a example for our class. So let us begin to solve this. Now let us begin. This example is before you. Now I will start the solutions. So dear students, look carefully the solution of this example. Now the first point that I want to pick up is the marginal distribution of x. This is what I am going to take the first. Okay, marginal distribution of x. How will you take up marginal distribution of x? For that I will prepare a table. Okay. So in this table we have to enlist all the findings. Okay. So here you have to take up xi values, and here you have to take up fxi values. Okay, gentlemen, how we have to calculate? The table is before you. You can see the table. So xi values are what? The leftmost column where x is written, those values are xi values, that means values of the random variable x. What are those values? First value is 2. Yes, first value is 2. Second value is yes, it is second value is 5, and then it is 7. 5 and 7. So these are the random variable values. So this first we will learn. Now we have to calculate the fxi. For fxi of 2. If you want fxi of 2, then you have to take the row against 2. The row against 2 contains what? So you see, if you take up the row against 2, so I will take up here and make the calculations. So that means when x is equal to 2, what are the values? You take up the values against 2, it is 1 upon 6, 1 upon 6, 1 upon 6. So you have to add 1 upon 6 plus 1 upon 6 plus 1 upon 6. You know that this is equal to 3 upon 6 is equal to 0.5. So this is the first finding, that is fxy, 0.5. This is when x is equal to 2, this is the probability function of 2. Next we will go for 5. So what are the values for 5? When you take up 5, for example, I will take up here, I will retain this for some time, fxc is equal to phi u if you take up. What are the values? Just see in the table against phi u along the row, 1 upon 12, 1 upon 12, 1 upon 12. So 1 upon 12 plus 1 upon 12 plus 1 upon 12, that is equal to 3 upon 12, and 3 upon 12 means 1 upon 4, that is 0.25. 0.25. So therefore, when phi u is the value of random variable x, the value of this probability function is 0.25. Okay, last one, 7. Against 7, look in the chart. Against 7, along the row, what are the values? One is 1 upon 12, 1 upon 12, 1 upon 12. Sorry, it is 1 upon 12, 1 upon 12, 1 upon 12. Okay, all the same. So it is also 0.25 because it is same. 1 upon 12, 1 upon 12, answer is already available, so it is 0.25. This way, the first requirement is over. Marginal distribution of x. Okay, next we will go for marginal distribution of y. So let us have another table. Marginal distribution of y. It is very simple. Just take up the table and put the values. This is y values, and these are the corresponding g yj values. Yes, let us begin. It is y j values of random variable y, and it is g y j. So these are the values of corresponding probability function. Okay, gentlemen. Now to get the probability distribution function of the y, you have to go along the column. You have to go along the column in the table. The first value of the y is what? The first value of y is 3. You can look in the table. It is 3. And next value is, after 3, what is the next value? Next value is 4. Next value is 4. And another value is 5. These are the 3 values that are there listed in the table. These are the values of the random variable y. Now to get there, so because we have got this, I will remove this. I will remove this and I will work out here for random variable y its marginal distributions. Now first I will take up the first value when g y is equal to 2. When g y is equal to 2, look in the table. What are the values listed along the column? Against 2. Against 2 it is, you can see. So I think it is y value is not 2, 3, sorry. It's 3. Against 3 it is what? Against 3 along the column it is 1 upon 6, 1 upon 12, 1 upon 12. Look here, first is 1 upon 6 plus 1 upon 12 plus 1 upon 12. So you can take up these values, and when you take up these values, what is the result? So that is equal to, you can see, you can work out, it is 4 upon 12 and it is approximately 0.333 and so on. So this is the first result. So therefore I will write here 0.3, 3 and 3. This is the marginal distribution of random variable y's value 3. When y is 3, it is the value. Next you go for next. It is g of y is equal to 4. When you take g of y is equal to 4, against 4 along the column, what are the values? You can see 1 upon 6, 1 upon 12, 1 upon 12. Same. You can see same, 1 upon 6, 1 upon 12, 1 upon 12. So therefore the same value you will get here for 4 also. That is 3, 3. And what against 5? When you go for 5, again you can see 1 upon 6, 1 upon 12, 1 upon 12. So same value you will get 0.333. So this way the first answer is complete. What? Determine marginal distribution is complete. This much if you do, you will get the first work done. So this is exactly there. So therefore this is the second table that you have got. Now gentlemen, when you have got these tables, you can very easily see that when you add up fxi values are also equal to 1. When you add because approximate values we have taken, but exactly when you add, this is also equal to 1. That is must. That is must. Then only it is joint probability, otherwise not. So this way you can see that first attempt you have gone. Next we have to go for covariance. Okay, covariance we will work out. So covariance, if you want to work out for the covariance, then for that first you want expectation of x. Expectation of x whose symbol is also mu x, and the formula is sigma xi, or I will write simply x into f of x. So that is equal to, so that means in this x values are 2 into its probability, 5 into its probability function, 7 into this probability, and you have to add, that is sigma means summation. So therefore it is 2 into 0.5 is first, look here, 2 into 0.5, then plus 5 into 0.25 plus 7 into 0.25. When you work it out, what answer you will get? This is equal to 4. You can work out, this is equal to 4. Now similarly we will go for expectation of y. Expectation of y is equal to mu y is the symbol, another symbol, and the formula is sigma here y into gy, and that you can work out in the similar manner. Second table, 3 into its probability function, 3 into 0.333 plus it is next is 4 into 0.333 plus next value is 5 into 0.333, and you can see that 0.333 is common. 3 plus 4 is 7, 7 plus 5 is 12. So therefore it is into 12, and that will be the answer. If you work out, it will be 3.996, which is approximately, this is also equal to 4. So this way you have calculate expectation of x, expectation of y. Lastly you have to go for expectation of xy. So let us work out expectation of xy. So gentlemen, when you want expectation of x, you refer this table. When you want expectation of y, you refer this table. But when you want expectation of xy, then you have to refer the joint probability table itself. So you can see there are 3 values of x, there are 3 values of y. So there will be 3 into 3, 9 pairs. So that means 9 attempts you have to add up here. X, y and j, y. X, y, j. These 3 continuously you have to take. Well, okay, we will start with the table. Look in the table. The first x value is 2. So we will begin with 2. 2 is paired with 3. First value of y is what? First I will write the formula here. Yes, gentlemen. Formula is what? It is sigma x, y and j, I, j. Means x, I, y, j. So this you have to take up the full addition of this. So let us work out. That is equal to, yes, first I will begin with x value, 2 I will take up. And 2 will be paired with 3, 2 will be paired with 4, 2 will be paired with 5. So all these pairs and corresponding j values are taken. First 2 into 3, and for 2 and 3 what is the j value? It is 1 upon 6 plus next again 2 is taken, 2 is paired with 3, now 2 is paired with 3, now 2 will be paired with 4. So 2 with 4, and what is the corresponding j value? For 2 and 4 it is 1 upon 6 again, and plus lastly 2 is paired. 2 is paired with 3, 2 is paired with 4, 2 is paired with 5. Now when you pair with 5, what is the corresponding j value? Again 1 upon 6. Okay. After 2, we will consider 5. When you take a 5, gentlemen, when you take a 5, again you have to pair 5 with 3, 5 with 4, 5 with 3, 5 with 4, 5 with 5. So therefore 5 with 3 we will take up, and when you take up 5 with 3, the j value is 1 upon 12. When you take 5 with next, 5 with 3 is over, 5 with 4, you will consider the j value is what? The j value in the JP table you can see it is again 1 upon 12. And then 5 you will take up, 5 you will take up with 5 itself. When you take up 5 with 5, the j value is again 1 upon 12. Okay, plus now 2 is over, 5 is over, next we will come to 7. When you take 7, 7 is again paired with 3, 7 is paired with 4 and 5. 7 with 3, 7 with 4, 7 with 3, and then j value for 7 and 3. J value for 7 and 3 is 1 upon 12 again. Everywhere it is 1 upon 12. 7 is paired with 3, now 7 is paired with 4. 7 is paired with 4 and it is 1 upon 12 once again. And plus 7 is lastly paired with 5 and it is again 1 upon 12. When you work out, you will get expectation xy. You will get expectation xy. And what is expectation xy? Expectation xy, you will find that this is equal to 16. You work out, please. Use your calculators and work out. You will get its value as 16. When you got expectation of x 4, expectation of y, expectation of x 4, expectation of y 4, and expectation of xy 16. Then lastly, covariance x comma y is equal to, formula is what? Expectation of xy minus mu x mu y. Expectation of xy is 16 minus expectation of x is 4 into 4, and that is equal to 0. Finish. This is your example. This way the whole example has to be carried out, and very easily you can see that this can be done. Okay, this is an example for 6 months or 7 months, so you can work out